Hi kids, previously we studied that matter has mass and volume. Today let us see how matter exists in nature. Let us get to know the objectives of this particular video. To get to know the three states of matter, to understand the characteristics of each state of matter, and comparing the three states of matter. Let us look at the different states of matter. We have liquid, gas, plasma, and solids. We'll be mainly looking at solid, liquid, and gases in this particular video. Let us try to understand solids, liquids, and gases a little better. To do so, we need to look at some of the examples in our daily life. Here is smoke from agarbatti, sunflower oil, a car, steam or vapor from a teacup, petrol, ice cubes, water, an apple, and air. These are some of the objects that we see in our daily life, right? Let us observe these objects here and try to group the similar ones. Here, some of the objects can be touched, some have a proper form, and some even difficult to hold. Let us mark the ones which have proper forms or shape and that which we can touch. And that would be ice cubes, a car, and an apple, right? Now let us look at something that does not have a proper form or shape, but yet we can touch it. That would be oil, water, and petrol, right? Now let us look at the ones that which does not have a proper form and that which we cannot touch too. That would be the smoke from agarbatti, steam or vapor from the teacup, and air, correct? So the ones that are marked in red are solids because they have a proper form or shape and these are objects that we can touch. Then comes the ones which are in the green. So these are the ones which you can touch and the ones which does not have a proper form. And then at the end we have gases which do not have a proper form or shape and it is very difficult to even feel or touch it. Here are some typical examples to know solid, liquids, and gases a little better. Previously we have studied that matter is made up of tiny particles, right? So let us try and understand solids, liquids, and gases with respect to the particles it is made up of. So, and also see based on certain characteristics, what do we get to know about solids, liquids, and gases? Like for examples, let us look at the arrangement of particles, the space between the particles, the bond between these particles, the position and the movement of these particles, which decides whether a particular substance is a solid, liquid, or a gas. And it also decides two more properties that defines these states of matter, that is volume and shape. Let us look at solids, liquids, and gases individually. Let us start with a solid. Let us look at the particles in a solid. Let's first look at the arrangement. If you can see, the arrangement is very orderly. You can see here that the arrangement is very compact. They're all very tightly arranged. Space between. If you look at here, then you can see that there is hardly any space between the particles. Let us look at the bond between. This picture is here to show you the bonds between the particles, and here you can see that the bond is pretty strong and hence that is the reason it is so orderly arranged. Let us look at the position. Because they have a strong bond, the positions are fixed. Over here you can see that the positions are fixed. It is not moving anywhere at all. Movement. You can see that these particles are jiggling about the same space. The position is fixed, but they are vibrating in that same position. Based on these criteria, we can know whether a particular substance has a fixed volume or a fixed shape. In this case, because of the tight arrangement and strongs between them, they have a fixed volume and a fixed shape. So generally, for solids have a fixed volume and a fixed shape. Let us look at the particles in a liquid. Let us look at the arrangement. You can see that they are slightly loosely arranged. You can see here too. What about the space between? They do have quite a bit of space between them. Then the bond between. They do have bonds, but they are pretty weak when compared to a solid. What about the position? Because they don't have a strong bond between each other, they can slide over each other and move about in a given space. What about movement? They, like I already said, they slide over each other, they move about in a space given. You can see that this particle does not have a fixed position and hence moves about in that particular space. I did tell that the bonds are not very strong between the particles, and yet they are not so weak enough to let go of particles very easily. Hence, they have a fixed volume, but the particles are not very rigidly held on to. Hence, you can pour a liquid onto a glass or onto a surface. That is the reason they do not have a fixed shape. So basically, liquids have fixed volume but no fixed shape. Now let us look at the particles in a gas. Let us look at the arrangement. They are very loosely arranged. A very loose arrangement. You can look at it here also. Space between. Because they have a loose arrangement, there's a lot of space in between. What about the bond between? They do not seem to be bound very tightly, or they do not seem to have a strong bond between each other. Hence, they're very free to move about. Position, because they are not held strongly and even the arrangement is pretty loose, they don't have a fixed position. I can't tell that this particular thing will stay here forever. Then movement, because they don't have a particular fixed position, or they are not held on together with a strong bond, they're very free to move about, and they keep moving about fast and in a very random manner. Because of all these criteria, they do not have a fixed volume or a shape. It's time to look at solids. Let us look at solids a little closely. What do you see? Can you observe how closely the particles are arranged, the way they are jiggling about in a fixed space? Let us look at this ball that is rolling down a path. Do you see any change in the amount of space it is occupying? Now let us look at this cylinder that is being placed in different places out here. Observe that no matter where the cylinder is placed, it still occupies the same amount of space. Let us look at the volume of a solid once again. Let us first take some few number of cubes, wooden cubes, and let us place them in different jars. So what do you think happened? Do you think the shape or the volume of this particular object changed after placing in the glass? No, right? That means to say a solid has a fixed volume and a fixed shape. It does not depend on where you keep it, the shape remains the same. Now let us cross check once again. When you place some sand, which is nothing but an example for a solid, in a syringe and try to press it really hard, try to compress it, it does not get compressed at all, telling you that the volume or the space that it occupies will always remain the same no matter where you place it or how much you try to compress it. We have been talking about solids having a fixed shape and volume. What about the sponge here? When you compress it, you are actually changing the shape and the volume of that particular sponge. So is it a solid? Yes, it is. The reason is that it is still made up of sponge particles which has air between them. So when you're actually pressing or compressing it, all you're doing is you're pushing the air out, hence giving you that illusion of compressing or bringing about a change in shape and volume of this particular substance. When you leave it, it will go back to its previous volume and shape, telling you that it is a solid too. Now let us look at a similar example to sponge, which is nothing but a rubber band out here. When you stretch the rubber band, you are bringing about change in its volume and shape. But the minute you leave it, it will go back to its original shape and volume, telling you that it does have a fixed shape and volume and hence it is a solid. Now let us look at liquids. Observe carefully how the particles in a liquid move about. Think, how is it different from a solid? Does it seem to be limited to a fixed position? Does it move more freely than a solid? Look at how the liquid poured in all these different glass containers have taken up their shape. This you can observe in your schools too, wherein each student has a glass bottle, a water bottle of different shape, and yet the water in it takes up that exact shape. Look at how the same amount of liquid looks different in different glassware. Why do you think so? The answer is pretty simple. The amount of liquid remains the same, which is 200 ml out here, but the volume of glassware are different. The liquid here occupies the same amount of space in both the jars. As there is more space in the flask, it looks as if the water in it occupies a lesser space, but it isn't the case. Similarly, in the cylinder, it seems to almost fill it, indicating that the cylinder occupies a little more than 200 ml of volume. You can try and do something similar to this picture. Take a glass of water, pour it into a different container with a different volume or shape. Then you try and put back the same in the same glass. Do you see any change in the volume at all? No, right? When you try to compress a liquid, you can see that the original and the final position are almost the same. Let us look at why is it so. When you try to compress a liquid, you can see that there is only little space between the liquid, hence you will not be able to compress a liquid too much. Observe this hourglass out here. You can see that sand pouring down from it is taking up the shape of that particular container. So is it not a trait of a liquid? Just like a liquid, it has fixed volume but no fixed shape. So in this case, if you take a grain of sand in your hand and observe its volume and shape before and after it comes down, you will be able to see that it does not undergo any change in its shape and volume, telling you that it is a solid and not a liquid. Now let us look at gases. Look at the particles in a gas moving about with respect to each other. Next, we can see balloons of different shapes with the same amount and mixture of gases, showing you that gases do not have a fixed shape. We already saw that gases do not have a fixed shape. Let us see whether it occupies a definite volume. When you blow a balloon, you are containing the air inside it, right? What happens to this air when you burst the balloon? Where did it go? Can't you fill the whole room you are in with the air inside that balloon? This proves that they do not occupy a fixed volume. They do not have a fixed volume. Let us see what will happen when you try to compress it. If you observe, when air is being compressed in this particular syringe, the original position and the final positions are completely different. Let us see why. When you try to compress gas in a syringe, look what is happening. The spaces between the particles are reduced, and hence the amount of compressibility or the amount of compression that you can bring about in a gas is very high. It's time to compare solids, liquids, and gases. The three states of matter exhibit different properties because of the following reason. The first and foremost is the arrangement of particles in these states. The next one is the bonding of the particles present. Then the movement of these particles present in each state. Based on these, the solids, liquids, and gases have different properties. Now let us look at the next picture. In here you can observe three containers. The solid coming out of the container holds on to its shape and volume. The liquid spilling out of the next container seems to change in shape but retains its volume. Observe the third container. Though it is still, it is letting the gas molecules to go out. Let us look at the compressibility of solids, liquids, and gases. Solids hardly compress, liquids slightly compress or do not compress at all, whereas gases will compress to a higher extent. Let us again look at the variation in the properties of solids, liquids, and gases. Look at when it comes to shape. Solids have a fixed shape. Liquids do not have a fixed shape and they take the shape of the container in which it is in. Gases do not have a fixed shape, takes the shape of the container in which it is in. Then let us see the volume. Solids have a fixed volume, liquids have a fixed volume, whereas gases do not have a fixed volume. Let us look at the compressibility. Solids are not compressible, liquids are slightly or not compressible at all, and gases are compressible to a higher extent. Now let us look at what we studied till now. The states in which most of the matter around us occur are solids, liquids, and gases. Solids have particles vibrating in a fixed position and very compactly arranged. The attraction between the particles is very strong. Hence, solids have fixed volume and shape. Liquids have particles moving about freely and loosely arranged. The attraction between particles is lesser than in solids. Hence, liquids have definite volume but not fixed shape. Gases have particles moving very randomly and freely. There is a lot of space between the particles and hardly any attraction between them. Hence, gases have no fixed volume or shape. They can be compressed to a great extent. The three states of matter exhibit different properties because of the following reasons. Arrangement of particles is very different. Bonding between particles varies. And movement of particles is not the same.